Okay, let's get started on this week's lesson, and we're going to do objective triangles. And at the end, I'll pull up the homepage and we'll decide what letter that is. There's a couple of things that I need you to know. When we're talking about triangles, we're going to be observing their angles and their sides. So I need you to grab a sheet of paper if you don't already have it, and I need you to take some notes. So the first heading on your notes that I need you to write is angles. And the next heading that I need you to write on your note is sides. So on this particular objective, the main thing when it comes to angles is we're looking for right angles. This should be refreshing your memory some, but I know it's been a long time. So a right angle is going to be worth 90 degrees if we were going to measure that with a protractor. And it's going to look like a perfect L. Now here's the kicker. It doesn't have to, the L doesn't always have to go this way. And remember this, that's a little telltale that it's a perfect 90-degree angle. The L can go like this. Now I want you to think about this. If I had the ability to pick that up and turn it and kind of look like a mountaintop, and on this objective, if you have the ability to pick up your laptops and Chromebooks, you literally might have to pick it up and kind of turn your head, because if you see right here, that is a perfect L. It's going to be tricky. So do you think that they're really going to give you the easiest right angle? Probably not. Not for a fifth grader almost going to sixth grade. So I doubt, like I have, serious doubts. This is for comic relief for Miss Caulfield, because I don't know why it always does that. I have serious doubts that it's going to look like this every time. It will some, but I'm just telling you, it doesn't have to always go this direction. It could come this direction, or it could flip upside down and look like a mountaintop. Okay, so I hope you have that in your notes. Now when it comes to sides, there's 3 different things that you need to know about the sides of triangles. The first one is it could be an equilateral triangle. Now, whenever I said that, I kind of emphasized equa at the beginning, and I hope you're already going, oh, that sounds like equal, and it does. So that means 3 sides, I'm talking about the sides, I'm not talking about the angles. 3 sides are going to be equal. All 3 sides. It's a triangle. All 3 sides. Next, it could be an isosceles triangle. And if that's the case, then that means only 2 sides are equal. Hope you're writing this down, because you're going to need this, even if you have to pause my video and write real quick. And the last is a scalene, which means nothing is equal. No sides are equal. And that happens sometimes. And you'll see that today, and I'm going to go through all 10 questions. So if you don't have this written, pause my video real quick and get it written, because you're going to need this. This is like the most important information. Okay. So now let's get started. So number 1, under triangles, which is the most specific description for the triangle shown. Well, the first thing I'm going to do is look at my choices. And see in your choices, you've got something and something, something and something, something and something, something and something. That means they're wanting a description of the angle, and they're wanting a description of the sides. So right off the bat, I hope that you can see that perfect L right there. And it actually is going to the right. I'm just going to go ahead and put that right there. So right off the bat, I know the description of the angle is a right angle. So this says nothing about a right angle, so that can't be the answer. This says nothing about a right angle, so that can't be the answer. This says something about a right angle, and this says something about a right angle. So I've already narrowed it down to C and D. Now I got to kind of look at the sides and see what description I can come up with the sides. Well, if it was an equilateral, that would mean all 3 sides are the same. And this is a perfect example of if you had your laptop, I wish I could pick my smartboard up and turn it, because honestly, it kind of looks like this side is longer than this side, And this is tricky, and if you have to redo this objective a couple of times, it's pretty short, so it won't, hurt too bad. But the truth is, this side and this side are the same exact. And whenever that happens, like on paper, then we usually put lines in it like that. And that's telling you that's the same length as that. But this side typically that connects the two sides is longer because look, see how it's not just like this. It's kind of like tilted if you think about it, which would make this side be longer. And so if two sides are the same and the third side is not, I've got two sides are the same. If you'll look at your notes, that meant isosceles. So your answer to this would be isosceles and right. Why is it not C? Because all sides would have had to be the same for equilateral, all sides. And if all sides are the same, it doesn't matter if you have it upside down, to the right, to the left, it's gonna look the same all three sides. But it doesn't. Right here you can tell it's like tilted, kind of. So your answer to this one would be isosceles and right. Uh-oh. What is the most specific description for the type of triangle represented by the traffic sign? Now look right here, there's only one choice here. So they're not wanting you to describe the angles and the sides. So let's just kind of start and see if we can eliminate some stuff. So letter A says equilateral. Equilateral, if you look at your notes, is that all three sides are the same. Well, let's think about this. Is this the same length as this? This the same length as this? Well, if you took your laptop and you turned it and it was like this, then you can tell that this side and this side and this side are all the same. And if you turn it again, you'll be able to tell that this side and this side and this side are all the same because it looks the same every direction that you turn it. So I'm going to call that equilateral. Why is it not a right angle? I mean, that's got like a curve on it. That doesn't make a perfect L by any means. Isosceles would mean that two sides are the same. If it was two sides, typically an isosceles triangle kind of looks like a Christmas tree. Typically, not always. Where you've got this side's the same as this side's the same and it makes this side be shorter. Typically, that's what it looks like. But I can tell, even if I turn this way, that looks exactly like it did if I looked this way. So I'm going to call that an equilateral. What's the most specific description for the triangle represented by the piece of bread? Well, I see a perfect L right there. So I'm going to call that a right angle right off the bat. So I don't think it's A, and I don't think it's C, because that says nothing about right. So I think it's either going to be B or D. So the question is, if it was B, right and scalene means scalenes mean no sides are the same. Or if it was D, isosceles means two sides are the same. And this is tricky. I got to think about this myself. If I turn my head and look at it like this, I can tell that this side's shorter than this side. And that would more than likely mean that side's longer. So I'm going to say this is a scalene. I'm going to say nothing is the same on this. So that would be letter B. Which of these are right triangles? Well, I mean, I don't see a perfect L here. A perfect L would look like this. A perfect L would look like this. A perfect L would look more like this if it was right on that angle. And so what they've done is they try to trick you. The answer is actually this, and they laid it down. So if you turn your head and look like this, you'll see there's a, whoops, I didn't do a very good job, but you'll see that there's a perfect L right there. So your letter's X. So I'm warning you, you're gonna have to maybe get up and turn your head a little bit. Oh, there's two. Okay, see, so it can't be A because the letter, it has to be X. So it's either X and Z or X and Y. Oh, well, let's see. Here's Z. Oops. Here's Z. There's a perfect L going that way. So I totally think it's Z, X and Z. Letter B again. Which triangle is scalene? And I'm looking at my answers and it looks like there's only one choice. So scalene means nothing is the same. If you turn your head on this looks just like a Christmas tree. This side and this side are exactly the same length. That's isosceles. Two sides are the same. If you look at this, that and that are exactly the same. This side's longer. That's isosceles. Letter Z, same thing. That looks just like a Christmas tree. That side and that side, that's isosceles. But I can tell you right now, that's shorter than that, and that's shorter than that. So this is the longest, this is the middle length, and that's the shortest length. Meaning nothing's the same. And that's the very definition of what scalene is. So that's letter X, which is actually letter B. B's a popular choice, isn't it? Okay, now it's next question. Which triangle is equilateral? Well, this time, equal, all three sides are the same. So if you picked up your laptop and you turned it, I mean, I can already tell you that side's longer than those sides. That side's longer than those sides. But look at Y. Like if you picked him up and you looked at him this way, he looks the same as if you look at him this way, as if you look at him that way. Like it doesn't matter how Y, like if you turn him, Y is gonna look the same no matter what. It can't be Z because that's like a Christmas tree. Those two sides are the same length and the bottom's shorter. So the letter Y is your answer, which is actually letter A. Which triangles are isosceles? And it looks like in my answer it wants two, which I should have paid attention to before. Okay, remember isosceles are two sides that are the same, and it typically looks like a Christmas tree, but not always. So let's see. I'm gonna kind of turn and look right here. This is tricky. That actually looks a little bit longer than that, so I don't think it's Y or W. I do think it's X because that and that are the same, but that side's longer. So it's gotta have an X in it. So it can't be B and it can't be C. So I've already narrowed it down to either A or D. So if the answer's A, then it would be X and Y. Let's look at Y. If I looked this way, yep. If I look this way, that side and that side look just like a Christmas tree. So I'm gonna say Y and X, which would be letter A. Scalene means nothing's the same. Well, this kind of looks like a Christmas tree laid over on its side, but look, you can tell this side's longer. Like if this was the same as that top one, it would stop about right there, but it doesn't. It goes on, so it might be that. I don't think it's X, because if you look at X, no matter how you look at it, like if you kept turning it, that would be equilateral. Oh my gosh, I don't know. This and this, that's isosceles because both of those are the same. So I think it's either W or Y. See, this side looks longer to me. Oh, so I got two choices. Okay, well good. W and Y, I think, are the choices. W and Y is letter D. What's the most specific description for the triangle represented by the billiard ball rack? This to this to this. If I flipped it over, would it look exactly the same? Yes. If I flipped it again, would that look exactly the same? Yes. In fact, think about the amount of balls that are on one side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That means 5 balls can go here. 5 balls can go here. 5 balls can go here. That means it's all exactly the same. So that's an equilateral. Equa. And last one, isosceles. I'm looking for two sides that are the same. Well, I can already tell you that that side and that side is not the same. That would be a funny looking Christmas tree. It looks like it's tilted a little bit. Let me look at X. Same thing. This side is longer than this side, so it's not that. Because isosceles 2 sides the same. Is that the same length as that? I think it is. And then I think this side's longer. So I'm going with Y. Let's see if we get the right answer. Ding, ding, ding. Yay. You did good. Hope that makes sense to you. So let's find where triangle is. It's down toward the bottom. It's going to be under geometry and measurement, and it's the very first one. So it's 4A on mine. I hope that's what it is on yours. So if you have to do it a couple times, so it's okay. No big deal. And you'll get better, but don't forget to have your notes and look at your notes, okay? So hope things are going well. Hope you're staying well. No sickness. That's what I hope. Okay. See you later. Love you all.